Hello, everyone. My name is Florian Weininger, and it is my pleasure to introduce the first speaker on track 2 of the Micro Frontend Conference 2024. She's a full stack developer at TNG Technology Consulting. Her focus lies on software architecture and test automation, and she is talking today about the challenges of integrating micro frontends. Please welcome Cathrin Möller, live out of our headquarters here in Munich. Cathrin, nice to have you. How are you today?
Yeah, thanks. I'm feeling great, and it's a pleasure to be here in this conference.
It is so nice to have you. Actually, you're the first woman to ever speak on the stage of the Micro Frontend Conference. So thank you very much for pioneering. And when you're ready, the stage is yours.
Yeah, I'm ready. Thanks. So, screen is shared, I guess. Yeah, now I see it. Perfect. Welcome to my talk about the hidden challenges of runtime integrated micro front ends. I would like to present you today some lessons learned from various project experiences, and I can tell you, not always is a fully isolated micro front end the right choice. Let me briefly introduce myself to let you know from which perspective I'm talking today. So I'm a consultant for more than 10 years, and this means I have worked for several clients, for several projects, from startup up to enterprise companies, and I've seen a lot. I've seen a lot of different architectures, and I know how to build websites with basic HTML and JavaScript, as well as with the modern SPA frameworks. And currently, I'm doing a lot of solution architecture and a lot of proof of concepts to make some architectures work. And I can tell you also from my sports life, I'm very stubborn. And if my customer wants something to work, I give my best and I try to make it happen. But I can tell at some points, sometimes I have to say, is the effort really justified? But coming to that later. Let's go back to our day-to-day project problems. In the day-to-day life, when we want to build a website, an application with lots of functionality, we might have to implement a lot of features. Even starting from the dashboard, from a single screen, there might be some widgets. A web shop, for example, might have a cart functionality, a search with a type ahead, and so much more. And usually, if you want to start building the start page and we have time, it could be done by a single development team. And they could try to identify areas, domains, components, and start getting them implemented one by one. But usually it's not the case that we have endless time. We want to go to market, and therefore more than one developer team is working at the application. And if we can clearly separate our domains, our features, this might work to let them develop in parallel. And a real application is not only a single screen, it's multiple screens, it's big complexity. And then usually we come to the enterprise world where we have 10, 20 development teams working on the same application at the same time. And a short recap why, especially in such huge projects in enterprise companies, Angular is often the desired choice. Well, it's an SPA framework like React or Vue. It has routing across screens, but the benefit for enterprise is often that it's an all-in-one package. So by Angular itself, from the framework, we get extra functionality like server-side rendering, like routing, state management, and so on. We get more than just UI templating, all from one framework. And therefore, it's easy in a big company if you learn Angular to switch projects or to hand over the code and somebody else could continue developing here. And also, if you might come from a backend world, having been a Java developer, the structure, the architecture in Angular looks quite familiar, and therefore it's easier to find your way through the code and be productive. Coming back to the daily life of development, if we have multiple teams working on a single page application, which is the basic standard working with Angular, usually you would start working in one repository, in one code repository on the same application. And what happens after a 2-week sprint? Well, all teams, they finish their features just in time at the end and raise a pull request. So they want to change the code. And the problem, even if you're matching just 3 teams, is the first team is lucky, they merge their code, and then the other teams have to suffer because they have conflicts, breaking changes, inconsistencies. They might have to retest their features with the merges just done by the other team. And this is time consuming. This is time consuming, especially in an enterprise world where the teams might be located in different regions in the world. They might work in different time zones, and they might not have the time to schedule meetings amongst and communicate a lot. And they would need API conventions to not have breaking changes in a reused library part, and they lose focus. And that's why, from an organizational standpoint, microfrontends are so popular in big enterprise projects. They fulfill the dream that every team all over the world can be independent, they can work autonomous on their own part of the code in reduced complexity. They do not need to care about breaking features from others. They can deploy independently. If they want to move up Angular from 16 to 17, they could just go. And also in such big projects, microfrontends would allow that external widgets, legacy integrations, outdated code from somewhere, some uncritical widget could still be seamlessly integrated. And ideally, really, each team would be in a microfrontend world completely separate. So each team could have their own source code repo. They could have their own pipelines and produce and release a new artifact whenever desired. And in the end, we get still the seamless user experience for the end user, having an app containing all the microfrontends, which is visual consistent. And that this is working, I would just like to mention once more that you need to consider that you need to take care of the app shell, the glue surrounding the microfrontends. And if there's any mounting logic, any initial context handover or anything, you need to be aware that the shell and the microfrontend APIs must be compatible. So only because it's a microfrontend, it might not fit directly into each and every shell, and also not the other way around. But let's come to the options. How can we structure our architecture? How can we have microfrontends? So microfrontends, they don't necessarily need to be runtime integrated. There's also a build time option, which is often forgotten and might make sense for smaller projects, for teams who can organize, who can maintain the same Angular version, who could work in a monorepo. And the benefit of such an architecture would be that it's fully Angular supported, that it's completely stable and easily testable. But as I said, in bigger, more complex projects across the world, runtime options become more valuable to let the teams be independent. And here we have 2 classic approaches. One supported by Angular is module federation, which is code-wise very similar to Angular libraries. And the second one is using web components as a wrapper around the micro frontends, which would also allow us to integrate other frameworks, even though it's not recommended. But for the sake of adding a simple widget on the side, on the screen, which is coming from a third-party company, it might be worth considering that a web component embedding can help us here. Coming back to the desired aspects. So many organizations, they want to have micro frontends with runtime integration. And then at the same time, there's often the wish of version independence. And version independence is not automatically possible. It's not automatically the same that as soon as we have a micro frontend architecture, you can have runtime integration. Version independence is guaranteed. And I can tell you from my experience that it's beyond full Angular support to make Angular compatible as a multi-version application. So they don't support downwards compatibility of all their sub-packages if you want to mix and match versions. So really the intention of a SPA framework like Angular is that it's used as a singleton, which comes us to the fully supported Angular mechanism to allow runtime integration, which is, by the way, same supported mechanism you could use for React. With module federation, we can have runtime integration, so loading parts of the application from remote URLs, while at the same time not losing the benefits of the Angular SPA. So many things are already solved technically using an SPA. Like there are communication mechanisms via Angular events. We have the construct of using dependency injection, having shared state, having services we can share across the application. And most important, I would say, Angular solves in this SPA nature this routing and the sub-routing that you can navigate to a certain screen where you have nested child screens coming from a different part, from a different module of your application. And another benefit is Angular is seamlessly back and forwards compatible if you want to make a transition from a build time library module to a runtime module federated module. So you can change your application to your needs with little effort, little development effort and configuration effort. If at some point you might want to extract a build time library to a module federated. Module federated, as I wanted to depict here, is really just changing a little bit of code, going from build time to runtime. And then what happens is basically that the import path of certain sub packages changes from a real path reference in your repo, in your folder, to a remote URL where you can expect to load a certain module. And here comes already one of the challenges with module federation. You must define at which remote URL you expect to load which type of module, which interface with TypeScript API you are expecting. And if you do not take care, and either the remote URL is not accessible, there's some course exception, or the module you are serving from there is not matching the correct type, you might come up with a white screen. So this is a risk of runtime microfrontends that you cannot test during your build if you will have such a fallout. And it might be different in a production environment than in a dev stage. And yeah, so in reality, module federation must be handled with care. And here comes again the need that you need to take care of your application shell as well. So a good application shell, which is organizing the load of these modules, might catch this type of exception and might avoid that the rest of the application is ending up in just a white screen. Coming back to module federation and what you can configure here. So module federation is intended to share packages in the browser that you do not need to load the same JavaScript code more than once. And in theory, if you look at the Webpack configuration for module federation, it looks like you can say you can make different versions, different ranges of versions compatible and make it independent. So from the theory, it looks like it could work if in the shell I have Angular 17 and in the microfrontends I have maybe some microfrontends with 17, others with 16, and it would work. But in reality, and trust me, I did a lot of proof of concept. As soon as the application reaches a certain complexity level, so it's an application using the Angular router, using the forms package for form detection, validity checks, and so on, even a version mismatch at patch level, not even at minor level, sometimes even at patch level, caused my POC to crash. And I got all kinds of exceptions. Form validation was not working anymore, and so on. And therefore, I would strongly recommend, if you use a module federation, please do not use this auto feature for sharing stateful libraries like the Angular dependencies, because otherwise there is a risk at runtime. Only at runtime you realize there's an exception and the whole application is not working anymore. And therefore, the recommendation is we can use module federation to make use of runtime integration and full Angular support, but I would not use it without ensuring we have version equality, even at a minor level. And to reach version equality, there are only two ways. We can have a governance, we can have a planning across the domain teams who build the microfrontends, that they update Angular versions synchronous, or we can have a monorepo when there's one global package JSON and we can define the specific version in here. So recommendation, we can't safely use module federation with more than one version. But beside these mitigations, to have a monorepo or to have governance, there's a way out. We could use a different pattern, a different additional pattern to build our microfrontends and still make multi-version integration possible. And this is done by wrapping in custom elements, wrapping as a web component, which is our second runtime integration option. And web components are, I would say, the modern iframe because it's more seamlessly integrated. It gives us more APIs and interfaces in the browser, but still the isolation is good enough from a DOM structure, from namespace structure, that you can mix and match multiple Angular versions and other frameworks in the same browser. And if we speak of web component, it actually means a set of vanilla.js web platform APIs. And the two APIs most associated with web components are custom elements and shadow DOM. So custom elements mean I can wrap my microfrontend as a custom HTML tag, and I could optional define some input parameters to give my microfrontend some initial context. And not necessarily you have shadow DOM at the same time, even though it's recommended for micro frontends in order to encapsulate CSS and avoid that the styling of the MFE is modified by different MFE or by the surrounding app shell, surrounding page where micro frontends are embedded with, and to get their own scope. And if we already have an Angular application, an Angular micro frontend, it's really easy to get our application wrapped, nested as a custom element, as a web component, just by using the Angular sub package Angular elements. We can install it, and then it's really a matter of changing a few lines of code. For example, in the app module, we can tell we have our Angular application and we want to bootstrap a certain component out of our existing Angular application as a custom element. And here we can say, for example, we have a widget, and please, Angular, inject me all the dependencies the widget needs to make it alive, to make it bootstrapped. So all the services, all the child components, everything, and build me this, bundle me this as a custom element that has the HTML tag, my widget. And then if you compile the application, automatically we get these multi-files from Angular, so the main.js, the polyfill.js, and so on. But you could just concatenate these JavaScript files, the runtime.js, and so on, and make it a single widget.js. So for this, I usually use a Node script that just has this concat option, and then I bundle my web component logic in a single JavaScript file. And then I can use it anywhere in the shell, in a CMS page, in whatever I like, but just using the custom element tag and having the remote source loaded, which brings my custom element alive. Because without the JavaScript source, the custom element would just be an empty HTML tag. And with this, really, it's feasible that I can have an application, even if the shell is not vanilla, even if it's made from Angular itself. I can have an application with any Angular version for the shell and any Angular versions for the MFEs. And there could be also already differences of multiple major versions, and the browser would not crash. It would work. A DOM tree separation allows us to do that. And if we worry about bundle size, if we have really multiple MFEs on one screen, we can still add module federation on top if by coincidence we have twice the same Angular version to reuse them. There's a lot on Manfred Steyer's blog post about this if you want to know more. But the beauty of this web component wrapper architecture has one case where it comes to its edges. So it's fine to use if the micro frontends embedded in the shell have widget character, as I call it, so they don't use the Angular router. If embedded micro frontends are single screen, they don't manipulate the URL of the browser, they are not navigating to sub elements, to sub components, everything is good. But if you have, for example, in a smaller application, one shell and two micro frontends at the same time embedded, you have, due to the web component wrapper nature, no longer a root application and two child modules, but we have three root applications just nested as web components. And therefore you have 3 times the Angular router module for root. And I can tell you, this architecture is not intended by Angular. Angular is intended to create single-page applications to use a singleton, a single version instance, a single instance of Angular that controls the browser. And this router, it seems so harmless, but the router API in Angular actually is very, very complex. If you look at their documentation, you will find out it's very large, it's very complex, and it has grown over years. And there went a lot of complexity into it, allowing main application and subscreens navigating seamlessly back and forth and working together. So I wanted to understand where was this problems coming from, having 3 times Angular router for root, and why is my application crashing? So I took a deep dive into the mechanics of the Angular router, what it did, to figure out if I could patch it somehow, if I could still get a solution with multiple web component microfrontends of different versions and the router and make it work. And to understand what's going on, let's make a brief recap of classic websites. So not SPA websites, but classic HTML websites. In a classic HTML website, you load your URL, you load your HTML, your JavaScript sources, and so on. And the page is built from a white screen and made alive. And one browser, your window, has one global property, which is the window location, which is reflecting your URL. And if you would manipulate this global variable and say, my window location is now a different one, a different URL, a different sub URL, if you would modify this directly, you get a hard reload. You end up at a white screen, your new HTML is fetched, your new JavaScript is fetched and interpreted, and so on. But this is not how single-page applications work. They seamlessly change parts of the URL and everything is changed on the screen and not reloaded from scratch. So how is this working? Well, Angular and also React and other frameworks that are from SPA style, they actually do a trick to get that soft, seamless reload and not the widescreen appearance. They act like a time machine. They don't manipulate the window location, they manipulate the window history. And they modify the history in the browser. So that if you want to navigate to a new screen, they do it like this. They pretend the current visited screen was one screen back in the history, and the screen we want to navigate to, we are already at. And this is indicating the browser, no, I don't need to load a white screen and reload my sources because I'm already at my target page and everything is fine. And this is all good as long as we have one single page application made by Angular, one instance which can keep track of its state. So the Angular application, the router, knows what manipulations were done to the browser history, and therefore it works using the browser back and so forth, and everything is synchronized. So the content on the screen displayed is matching what we expect from a URL. But imagine now our use case having an application shell and 2 web component microfrontends, all using Angular, all wanting to route and to manipulate the history. Yeah, the problem is they do this in silence. There's no global browser event available if somebody changed the URL indirectly via this history manipulation. And this leads now to all sorts of problems like race conditions, corrupt history, multiple redirects, unfunctional browser back, endless loops, state loss, and also that maybe the URL is showing we are at page 2, but the component that should be visible on page 2 is not yet shown. And there are some ways around this. Also from Manfred Steyer, very good blog post exists about how to solve this on a first level orchestration. So you could say you have a dedicated start path of your URL, like microfrontend 1 or microfrontend 2. And from there, only the microfrontend is allowed to manipulate further the URL. So the shell can only reach the starting page of a microfrontend, and then the microfrontends could navigate further. The problem here is this would require lots of discipline from all the teams working on the microfrontends. They all would have to implement these lines of code, these security mechanisms. And you cannot expect, like I'm sometimes asked, I work in the shell team, that the shell is so stable and unbreakable that MFEs can't destroy our browser back or navigation or URL. It's really sensitive. It has to be taken with care. And there are also some regex parsing, URL parsing, which comes with a risk which would have been encapsulated using Angular router in a normal way. And this top level linking solution has its limits. It might be we have an application that requires deep linking, how I call it. So you want to go from the shell not only to the starting screen of a microfrontend, but directly deep link into a nested subscreen. So for example, we have already loaded microfrontend 1, page 1, and decide we have a certain notification in the shell. We want to navigate to page 2 of the same already routed microfrontend. And what happens if we do this via the router? Well, the router event is triggered. The shell Angular router indirectly manipulates our URL, knows where we are. The URL in the browser is actually changed, but the inner MFE, which was already mounted, did not get this change because there's no global event in the browser if the URL is changing, if you do this indirectly with this dirty history manipulation trick all SPA frameworks are using. And yeah, what can we do about this? If the problem is only this missing event, we could create the event ourselves. So a solution could be a custom solution, a fragile solution, but a solution. A solution could be to send such an event globally in the browser, that the URL has been changed by whoever. And if you want to go to the solutions that are as native, as vanilla as possible, we have two different event buses and event types we could use in the browser. And one is using custom events that we can send via the event bus, which is just a normal DOM event, a DOM element. And we could use the broadcast channel API, which also has full browser support of all modern browsers, where we can send broadcast messages. And the solutions, they differ from how they work and how they are shared, how global they are. Because custom events, they work only in a single tab. And with broadcast channel, you can synchronize all tabs. Depending on your requirements, you might want to use one or the other. So how does it look using custom events? We have the shell. Let's say the shell manipulated the URL. It can send a URL changed event with the information, what is the new URL, and MFEs can listen to it. And it's really simple. It takes a few lines of code, and you could do that. And if you use custom events, you can have a separate URL, a separate context in each and every browser tab, while for the broadcast channel, which also has a very simple and easy syntax, you would share this information across all tabs, even across all browser windows and iframes, which might be a problem if you use it for something like URL change, because then you cannot have two different subscreens of the same application open at the same time. Depends on your requirements. And one problem that comes out of this communication patch solutions is you must have a matching API, must have a lot of conventions between the shell and the micro frontends that they are compatible. So ideally, for sure, you use the same event bus. So either the custom events with the DOM or the broadcast channel, and also the event format to parse it in the code, to listen, to interpret, or to send it should be similar structured. And here we have a very good guidance of the Cloud Native Computing Foundation, which hosts an NPM package with our cloud events. This format is a JSON format to structure events. You can also use this for Kafka, for backend events. It's not only limited to JavaScript, but here we have certain default attributes defined that help us synchronizing the events, like an ID, a type, like a topic, and actually then the data object where our information lies in. And with this ingredient, so using cloud events with one of the options to send them around, and the Angular router used as much as possible, we can achieve a deep linking application even with multi-version web components, micro frontends. So that's really great. You need a little bit of logic for sure for the sequence, which URL change is affecting whom, and some router state synchronization and so on. But by this, you could make it work that you have deep linking capabilities, that browser back is working, that bookmarking is working, and so on. One small example for the screen deviation I've shown earlier, how this is now working. So imagine we have the browser, it has its URL reflected in the form of the window location path name, and we have a deep link inside the shell made by Angular. We are navigating to page 2. The URL is changed in the browser indirectly via the history. Therefore, the micro frontend does not know we navigated from page 1 to page 2. But if we would now patch this by making the shell send on navigation end, on making this change, such a cloud event that the URL has been changed, and to what? And if the MFE has a listener installed to this event, it can recognize, oh, my known state is I'm at page 1, but actually now somebody navigated to page 2. And it could change this internally, synchronizing its state to page 2 to know we are now at page 2 and therefore display the correct content that belongs to page 2. I hope I made it clear today that it's not so easy to get a fully isolated micro frontend architecture working, especially if your organizational requirement is also to support multi-versions of even the same framework. There's some developer experience downsides, some efforts to make this stable, to get a stable end product again. And I would really recommend, if the project is small enough, if teams could talk to each other, you might think that a monorepo mustn't be a bad choice. And a module federation in a monorepo can work really well if you have then there the same version. If you want to embed web components with different versions, as long as they are widgets, so no router involved, single screen, I can also totally recommend using this Angular Elements wrapper and just use them. There is no complexity to solve because the router is not in there. But as soon as you have a complex multi-routing architecture, be aware, I just sketched some parts of what's needed for this custom solution. It is a lot of effort to define the sequence flow, to define the matching API, to synchronize the events. And it's solvable, but it comes with a complexity price. And there's no flexible solution on the market. Angular is not intending to provide this as a supported mechanism. So you have to solve something on your own. And be also aware that a web component architecture, if you use multiples on the same screen, will add complexity and will increase bundle size as well, where you might want to consider adding module federation on top to reduce bundle sizes, which is another complexity driver. So I would not recommend unless you need it. Thank you for your attention.
Cathrin, thank you so much for the wonderful talk. We have some interested questions from the audience, so if you still have some time, then we would gladly go over them. One is the second question of a series that was also answered in chat already, but here is a question that is especially for you. The additional question is, do teams share UI components as a shared library, or do they duplicate them from one to the other?
Yeah, that's the thing also why the teams are stuck, let's say, a little bit with Angular, and they have a big Angular atom level UI library, which is indeed supported to be stable for all Angular versions. So if you are still at Angular 15, you can use it. But if you want to have the latest UI components, you might need to upgrade to Angular 17, which also brings the wish that teams who want to use the latest UI elements can update anytime and do not need to wait on synchronization with App Shell and other MFEs to make that switch.
Okay. The next question would be, is the create custom element web component and API from Angular stable, or are there any gotchas experimental parts about it?
No, it's super stable. It exists since multiple versions, and under the hood, there's a vanilla JavaScript create custom element mechanism, but Angular adds on top these mechanisms to inject all dependencies to make it bootstrappable. But it's super stable. It exists at least since 3 or 4 major Angular versions.
Okay, awesome. And here are specific questions to your talk. Have you used the broadcast channel in practice? What was the use case?
Yeah, we actually use the broadcast channel as the event bus of choice, and we use it for URL synchronization, while we have a correlation ID that we can still separate the tabs to not have the same URL necessarily in all browser tabs. And we also use it for some initial mounting context handover. Instead of input attributes, we share the context, the product ID that has to be set.
Okay, very nice. Then another question regarding the broadcast API. Could you give an example why different tabs should be notified that their route has been changed and when using broadcast message API?
Yeah, this is the example. It's not needed because only the distinct tab should know. But as I said, there's a workaround with a correlation ID that's different in each and every tab that you can separate. but it might be relevant for overall context that you synchronize between the tabs.
Okay, these were all the questions that we had. Thank you so much for your time, Cathrin. It was awesome having you.